sides are going to be equal. So if you don't remember what a 45, 45, 90 triangle is when the hypotenuse is 1, do Pythagorean theorem. It's going to be x squared, which is our x, plus y squared equals c squared, which is just 1, right? But we know these two values are the same because if the angles are the same, the sides are the same. So we can just substitute. It's really just this. 2x squared equals 1. We're going to take a break in a bit, but not right now, Kylie, okay? Divide by 2. X squared equals 1/2. We're going to square root both sides. X. Square root of 1 over square root of 2. Square root of 1 is just 1. Root 2 is in the bottom. That's not okay. How do we get rid of a root 2 in the bottom?
Multiply by root 2 over 2.
Why is this okay? Why can I multiply just on one side? Because it equals 1. Same number of the same number is 1. We don't have to do it to both sides because it's identity, right? So we get 1 times root 2 is root 2 over root 2 times root 2 is 2. So x is root 2 over 2. Turns out since y is equal, this is also root 2 over 2. However, you should know that when we take a square root, there's always plus minus. So this is really plus or minus root 2 over 2. However, we know it's positive because look which direction x is going.
To the right.
To the right, which means positive. Y is going up, which is also positive. If I drew my triangle over here, that would be different. Our x would be negative. Our y would still be positive, though. I got an aha moment. Yes?
Wouldn't you just know that it would be root 2 over 2 because it was from that triangle?
Right, except it could be positive or negative. Watch, I'm going to draw a triangle
you know
over
what
here.
direction it is.
Oh, God.
45, 45. Same dumb thing. However, this is our x, which is going negative now, so it's negative root 2 over 2.
Well, how would, okay, well still, it doesn't,
That matters.
how would you know which side it was on if you were just given?
Because 45 is over here. This, the angle I drew here, is this line. That's not 45 degrees.
Right,
This
exactly.
angle's different.
So, but if it was 45 degrees, you would know that it would be root 2 over 2. That would be a
Yes, it would be a root 2 over 2, but you wouldn't know whether it was positive or negative unless you drew it out.
But yes, you would because the degree would be different if it was on the other side of the...
This degree is the same. This degree would be different. You're right.
That's right.
You're right. Exactly, it would. However, unless you memorize that, 135 degrees, also known as 3 pi 4, 3 pi over 4, is here. If I asked you for tangent of 3 pi over 4, you wouldn't know that it was negative or positive, would you? If I just gave you that. You'd have to draw it out. And after you drew it out, oh, of course x is negative and y is positive, right? You just need to know that it could be either or, and you need to check the unit circle to figure out which one it is, okay? Cool. So, using this guy, because this is the guy we were talking about, right? It's our y over our x. Our y is this, our x is that. Same number of the same number is 1. So, the tangent of pi over 4 is 1. Look which direction it's going. It goes this way. If you forget that tangent goes like this, okay, then you can plug in the point there and figure it out. I'm teaching you what happens if everything else goes to poop, okay? If you plugged in this, negative pi over 4, you would have gotten negative 1. And you would have realized, oh, it goes like this, right?
What goes this way?
Cotangent. Because cotangent is the reciprocal. It flips. Last one we're going to graph.
Squid?
Is there a gif of me?
No.
Yes!
Squid
Yes,
looks
there
like
is.
And it's like cosine or sine, I don't know what it is, and he goes like this with his arms, and his arms go like this.
Like this for sine? That's great. Or no, this would be the squid, so this is cosine because I'm the y-axis,
You're the
right?
squid.
And then you've got to do like
Here,
this for
No,
sine.
show him again.
If it loads.
Yeah. Okay, we'll take a break in a second. I want to do this.
Cosine, squid.
Look at all the stuff you're missing. Let's do secant.
Secant.
Secant is the reciprocal of which one?
Sine. Cosine.
Cosine.
Oh.
Because cosine sounds like it goes with cosecant. They're meant to be, but they're not.
But they're not.
Again, I'll read you the poem. I will read you the poem. Okay?
Sorry.
I once knew a boy who fell in love with a girl, who smiled at the thought of her name. The name is what's important here, right? I once knew a girl who fell in love with a boy who felt the very same. But it became a struggle and the timing was wrong, and love decided that they didn't belong. Cosine theta, cosecant theta. They sound like they should be together, their names match, but they're never together, ever. They're always with the wrong guy. Cosine's always with secant, and cosecant's always with sine. Will they ever figure it out? same thing as this. What does that mean?
That.
Well, when you plug in numbers, right, pi over 2, 0, you can plug it in there and take that. You get the right answer, right? If I plug in 0...
Who's here? Who goes there? Daniel Harris.
If I plug in 0 for x now, cosine of 0, well, on our graph, or on our unit circle, cosine of 0, well, that's the x, right? So it's 1. 1 over 1 is 1. And you could graph it that way. However, I'm going to teach you another way, because I just kind of did the whole plug and chug method, right? Plug it in, keep on going. Another way to think of it. Another way to think of it. Graph cosine of x. Okay, graph the reciprocal first. That's awesome. I love SpongeBob. That is awesome.
That's you.
All right, it is. So no talent, no talent. All right, so here we go. Let's graph cosine.
You've got talent. School botanicals, you have no talent.
If anybody else other than our class watches this video, my educational career is over.
I am ugly and I am proud.
Okay, so here we go. Here we go. Here we go. Here we go. Let's plug this in. We're going to graph regular cosine. So first graph this, okay? Graph the reciprocal function, okay? Graph this. When we get 0, it's 1, right, for cosine? 1. We plug in pi over 2, we get what? The x value, because cosine's interested in x, 0. When we plug in pi, we get negative 1. When we plug in 3 pi over 2, we get 0. When we plug in 2 pi, we get
Uno.
Good, so we get this. I'm going to tell you right now it's safe to duplicate this, because it's a squid, right?
Oh my
Oh my
god.
goodness.
What's happening?
Do they have to have sumo wrestling class right now? All right, so this thing, right? Watch. Watch. I'm going to do this one in blue. How do I do it? Secant is the reciprocal of cosine. Cosine flips. I'm running out of water here, okay? I'm pretty thirsty, and Mountain Dew's not helping. Cosine, it's the reciprocal. Pay attention, this is important. This is the payoff. Cosine, this is the graph of it. The reciprocal flips it. It flips the graph, just like it flips the fraction. It flips the graph. Watch. See how this u is going up? Now the u is going down. See how this u is going down? Now it's going up.
Wait, does it literally, is the blue literally what the secant is, or is it like...
This is a helpful tool, right? This is not the graph. The blue is just what it is. Okay? So, but if you draw this as a tool and leave it there, that's fine. I understand what you're doing. But the blue is the actual graph. And if you put it in Desmos, you'll see this thing. Again, this guy's going to go down. This guy's going to go up. If I kept going, he would go up on this side too, right? Same thing here. However, last thing you got to remember. Last thing, up here. Last thing you got to remember. 0, when we flip that, 0 over 1, right, is how we write 0 in fraction form. When you flip it, when you take the reciprocal of that, it's 1 over 0, undefined, therefore we need an asymptote.
It's a bloody asymptote.
Asymptote, yep.
It's not asymptote.
It really is.
How did the lady pronounce it on the video?
Sorry, Sherry, whatever your name is on YouTube. Oops,
Asymptote.
I did it in the wrong spot.
Asymptote.
We love your videos. You were very helpful for those of you that watched.
Oh my goodness.
All right, quiet. That's why we get asymptotes. Okay?
Oh my god, that was funny.
That's why we get asymptotes. Because when we flip 0, it's undefined. Do you understand? At the zeros of cosine, we flip it, right? We flip cosine. But when we flip the zeros, it goes away because it's impossible. You can't have 1 over 0. So we put an asymptote. So the graph of cosecant, y equals cosecant x, isn't this. It's just the blue part. If you leave this cosine in there as kind of like a thing to help you graph it, that's fine. I don't care. But the real graph is just this thing. That's it. In this case, we do need to label our y-axes. Notice I labeled them. Because where these things start matters. Okay, so let me grab my spear. Okay? Graph basic trig functions. We did it. We can do cosine, we can do sine, we can do tangent and cotangent. Tangent and cotangent. Remember, tangent goes like this, cotangent goes like that, right? If you don't remember it, plug in a point in between. Secant and cosecant are just the reciprocals of cosine and sine. If you can graph sine, you can flip it and get which one?
Tangent going up on the
If I flip sine, which one do I get?
Wow.
Cosecant. If I flip cosine, I get secant.
Secant.
Good. Question.
Is tangent's little arm on the right, or is tangent?
If you don't remember, you need to plug in pi over 4.
What can you tell me so I know?
What if I don't plug in pi?
Tangent goes this way.
So you're.
No, it goes like this.
Perspective matters, guys.
Wait,
From
so
your
you-
perspective, it's right. I'm doing your perspective,
Okay, so
So it goes
my,
like that.
right?
Goes up to the right.
so it goes up to the right.
Goes up to the right.
Yes. I could confuse you right now with the left-right joke and right versus wrong, but I'm not going to.
Please don't.
All right. But I thought about it for the record. All right. We're gonna take a short break, and we're gonna come back
Oh
to all
my
this stuff.
god, good, because I'll speak.